Okay, so we're going to continue working on the line of best fit today. And today, as we get started, I want to talk to you about lines of best fit. Okay. So when you have a line of best fit, the whole purpose or the job of a line of best fit is to split the data in half. Okay. So you should have an equal number of points above and below the line. So if you take a look at this first one over here on the left, this one's really easy to draw because the points are really close together. And we see that to draw a line, I just lay a ruler down, figure out where the middle is, I'm going to draw that line. Okay. Same thing with this one. I'm going to draw a line kind of in the middle where it splits. Now, a line of best fit doesn't have to go through any points. It just has to split the data. Okay. It has to split the data. Now, this one we see is negative. It's going down. The points are really spread out. And if you remember, the more spread out the data is, the bigger the IQR is in the box plot. And this one even has an outlier. Okay, an outlier, remember, is a point that doesn't really fit in the data set, and an outlier often shows up in a scatter plot. Okay, so when we draw a line of best fit, there definitely are some patterns. Okay, and this kind of is going to lead us into what we move into this next week, which is correlation coefficient and how strong relationships are. So this one's pretty easy to draw a line of best fit because the points are really close together. Same thing with this one. And I see that this one's going down, this one's going up. That makes sense. Positive slope, negative slope. Well, the more the points are spread out, the harder it is for me to draw a line. So if I draw a line here, is that a good line of best fit? No, that's not in the middle. So I really need to kind of figure out where's the middle of this data. And that looks pretty good. Same thing with this one. The middle of the data. I want approximately the same number above as below. And maybe that one's not great, but remember, anytime you're drawing a line of best fit by hand, it is an estimate. Okay? It is an estimate. It's only with technology that we can actually come up with a true, accurate measurement of the line of best fit. Okay? Because technology doesn't make mistakes. We make mistakes. Well, what if we have such a random set of lines or points that I don't even know, how would I split this? I kind of think the middle is somewhere in that area, maybe even a little bit lower. So maybe even down here. Well, that's a zero slope. Okay, that's a zero slope, which is going to come into play when we talk about relationships, because the easier it is to draw a line of best fit, the tighter the points are together, the stronger the relationship is. Okay. Well, this one, same thing. I know it's negative, but it's kind of in the middle. That one's a little bit harder to draw a line. Okay. It's a little bit harder to draw a line. Okay, now let's take a look at this data and let's see if we can figure out what it is telling us. So we've got this data, we've got this line of best fit. We are going to come up with the slope, the y-intercept, the y-equals, come up with the meaning of the slope, and then use this to estimate. Okay, use it to estimate. So let's start by finding our b. Well, the b looks like it's about here. And if I think about what's going on here, it's counting by 2500s. So if I kind of broke this up, that might be about 3,200. Maybe that's, I'm going to say that's 3,800 or 38,000. 38,000, not 3,800. Okay, I'm going to say that's my starting point, 38,000. Now I'm going to look for two good points. Okay, well, I see one point here that looks like I could use pretty well on my graph. And then I don't really have any other ones that look super good that are like an exact corner. So I'm going to estimate that this one is in the middle. Okay, I'm going to estimate that that is in the middle. So what is halfway between 75,000 and 50,000? What number can we say that is? Well, the difference between those two is 25,000. So if I divide those, I know the difference is 12,500. So I'm going to say that this is 62,500. Okay, so I'm going to start at 62,500. I'm going to go up to 100,000. So 100,000 minus 62,500 gives me 37,000. And I'm going to go from 40 to 60. So that's a range of 20. So my slope so far is 37.5 over 20. So let's divide that. 37.5 divided by 20 gives me 1875 over 1. Okay, 1875 over 1. So what are we talking about here? What are these? What units? Well, the 1875 is average annual income. So it's money, it's my increase in money because it's income per year. So what does that mean? Well, it means every year my income increases by the $1,875. So that's kind of my estimate. Is I can say that based off of what I have, my income is going to go up by 1875. Okay, so that would mean that I'm going to write my slope as 1875. That's technically over 1, but my slope will be 1875. So my equation would be 1875x plus 38,000 would be the equation of that regression line, or my estimated equation of that line. Okay. All right. So now we're going to use that to estimate. Okay. So we've got y equals 1875x plus 38,000. It says estimate the money if age was 80. Well, is that my x or is that my y? Well, age is x, so the 80 would have to go here. So 1875 times 80 plus 38,000 should give me how much money I could anticipate my income would be. So 1875 times 80 plus 38,000 tells me that I should be making 188,000 if my trend line would continue. Okay, if my trend line would continue, and my growth rate would be the same if it would be consistent. Well, now let's see what happens here. So estimate the age if I had $300,000. So where does this go? Is that my X or is that my Y? Yeah, it's the Y this time. So I have 300,000 is equal to 1875x plus 38,000. So the first thing I'm going to do is subtract my 38,000. And that gives me 1875x equals, so 300,000 minus 1875, or sorry, minus 38,000 is 262,000. And then dividing by my 1875 gives me 139.7. Well, that would be years. Okay, so I would have to live to 139.7 years old if I wanted in this trend line to be at $300,000. So, hey, with technology happening and the way that we're living longer, you never know. Maybe we could live that long. But it would be nice if my income would increase at that rate. But the whole point of this being you can substitute in for X and substitute in for Y into your equation once you have your equation for your line of regression. Okay. Keep in mind that as you are drawing your line, it is an estimate. When technology draws your line, it is much, much more accurate because we are not using human error to come up with our line. Okay, so as you're looking at your activity today, what you're going to see is you've got your graph like this, and you've come up with a trend line. Okay, so you've got number of sold, which is your bikes, and you've got your price charged. And what you're going to need to do is find your slope. Okay, find your slope and find your B. So your B should be somewhere around that, and you've got a couple decent points for slope here that you can use. So that one's a pretty good one. I actually can read that one because that's at 500. And I see a pretty good one right here. So maybe I want to use these for my slope. It's kind of going to be up to you what you want to use, but keep track of what your scale is. Okay? Keep track of what your scale is. And if you want to do this with two ordered pairs instead, so find two ordered pairs on your line, then make sure that you're using y2 minus y1 and x2 minus x1 to find your slope. Okay? So this point would be 137.50, and this point would be 800 and 500. Okay? Now, excuse me. Keep in mind that in this case, this is number of bikes and this is money. So when we come up with our values, what we're seeing is we see a trend line that the more bikes I sell, the lower my cost is. Okay, which makes sense because if you have more product in inventory, you tend to lower your price because maybe you're overstocked, you have too much inventory. Okay, that kind of thing. So as you're working today, that's what you're going to be targeting in on to kind of come up with your equation. All right, so finish up your line of best fit activity. Reach out to us if you are struggling on some of those questions and how to come up with the math, and we'll finish this up and move on to our next one.